Hey everyone, we are wrapping up the exercise, but we've got one last thing to chat about, pricing. Let's dive into my AWS spending and see if using AWS Lambda in my app design was a smart move for my wallet. Apparently, first thing to start with is going to AWS Management Console and searching for the Cost Explorer and checking what was the most expensive resource I provided for my Terraform configuration on AWS. And we see here on the page that my spending are not too many. On average, it's like half US dollar per day, but there is one exclusion here. And overall, all my spendings are mostly about, let's check it in the Cost Explorer. But I believe that's mostly about Elastic Cache. So I can filter my spendings by service. And if I choose Elastic Cache, I will see that it's probably only Elastic Cache that costed me some money. And if, for instance, I would choose AWS Lambda, no, just Lambda, sorry. It costed me nothing. Why did it cost me nothing? Why I didn't pay for any Lambda call? Because there is a free limit of Lambda calls and I didn't exceed this limit. And let me check more. Let me calculate the cost for the Lambda calls because there is a great AWS tool for calculating your spending on AWS Lambda. Let me search AWS Lambda. No, Lambda pricing calculator. And here should be the page on official AWS website. Might be this one, or probably this one, AWS pricing calculator. And I should start from selecting the service. The service should be Lambda. Could I provide it this way? No, this doesn't work. Yes, this should be it, AWS pricing calculator. I should be more specific. It should be about AWS Lambda. And I start with the region. Let me find it, Europe Central. Yes. And this Lambda includes the free tier. That's why it didn't cost a penny. Number of the requests. I can't estimate it, but let's say there are 2000 requests because our application is kind of efficient. And if we run, let's say, 20 quizzes, there won't be more than 100 requests per each quiz on average. And the duration in milliseconds, I haven't explored the duration, but I believe that's something about 500 milliseconds per request. And most of this time, the majority of the time, the Lambda is just starting. And if it's warmed up already, this time could be the half of this amount. So might be 500 is upper estimate. We'll check it later, but let's check if each request is 300 milliseconds. And the amount of memory allocated shouldn't be too many. Not sure, but let me type this value. Okay, do I have calculations already? Lambda costs monthly, $0. But to be sure that our resource consumption for the Lambda call and the duration of the calculations computation of the Lambda working time is not far from my estimation here. I should go back to check the Lambda in AWS console and check the statistics. Here what I have, I should have Lambda and I should have statistic on my Lambda calls. If I don't have any, I might run my quiz one more time. But there are some metrics, and these metrics are for all Lambda functions that I might have, but I have just one. So could I go back to functions and select my only Lambda function and check the monitor for the last week? No, no data available. Okay, I spent too much time without running the quiz even once. So I'm gonna go back to check my website address. Actually, instead, I would go to AWS API Gateway and check the address there. Oh, no, again, sorry, that's S3. I have a static website in S3, and there are two buckets, and one bucket is for quiz data, and the other one is for the website itself. So this one. It probably should be somewhere here in properties, and I'm searching for anything about the website. That should be somewhere here. Yes, static website hosting. And this URL would lead me directly to the website, and here it is. So now I would go and run a short quiz, but I want to pause my video here. The game is over, and let me update my statistics here. That should be it, but the charts are probably still being updated. Yep. And let's see the duration. Oh, I actually overestimated the duration because it was only 17, 18 plus something milliseconds on average. No, sorry, 34 milliseconds per one invocation. So if I go back to the pricing calculator, let it be here, and the duration is only 61 milliseconds. Do I have also memory metrics here? Not so sure, but if I filter by resource, no, probably the same statistics. So I should explore the statistics in more detail and determine the metrics for my pricing calculator for AWS Lambda more precisely. But again, I believe the amount of the free tier should be enough to run might be several hundreds, maybe even several thousands of quizzes. And if I recalculate, could I recalculate? Yeah, that's easy. Still, I'm in a free tier. But still, there is one cost inefficient component. And this is AWS Elastic Cache. Elastic Cache costed me 11 something, oh, $14 US dollars per month. Probably that's not only the Elastic Cache, because I provisioned other resources as well, and these resources could cost me some money. But the winner in this nomination is Elastic Cache. It costed up to 11.59 US dollars. Uh, So this is the majority of my expenses here, excluding this particular spike. But the spike absolute amount is not substantial. So I paid the most for Elastic Cache. And of course, it's not a cost-efficient component. And of course, I can choose other options. For instance, if I would go and change the Elastic Cache for, say, DynamoDB, most probably I would pay less. And let me also remind you that the Elastic Cache Redis is not the perfect choice for our memories, for our persistent memory for our service, because it's not persistent. Because also there could be a collision in couple lambda, AWS lambdas writing the data under the same key. And the previously calculated data that's is being written in Elastic Cache could be erased and could be buried under the new data. So that's a problem, and that's why my solution, my current application design is just for educational purposes. In production and even in a real life product that is targeted for a wider audience, I would go with more robust and more suitable solution on the memory on the persistency side. I believe for this limited exercise that's enough about cost efficiency, and my next stop is probably the solution perspective, like what can I do out of this very project if I can fork my project, if I can invest more time in implementing one or a couple more board games or similar applications, what limitations do I have with the design? This is the current design, and all the components are good for like state machine that's being invoked, that's being called periodically from the client, but on the other hand, this state machine is not being called too often. And during the gaming session, there is no component that works always, that it is being called, is performing some job constantly without interruptions. And this component, yes, I'm not exactly correct. I'm not quite correct here. I have such component. This is Elastic Cache Redis, and also might be in a way, in a sense, AWS API Gateway is other component that's always on duty. But the core component is AWS Lambda, and it executes for 60 milliseconds on average. And it runs some code in with a limited amount of memory and processor units, processor resource. So this is a cost-efficient solution, and I don't need a server, a dedicated server, and an AWS, say, Elastic Cache instance to process my queries, to maintain a connection with the user, the live connection with the user. Instead, each call is being processed by the Lambda, and upon completing the processing, the Lambda is being immediately terminated. But on the other hand, if I want to implement a multiplayer board game with human players, multiple human players, and might be, but not necessarily computer artificial intelligent players as well, I'll need something extra. And let me show you what I mean. What I need is WebSocket connections. So the majority of board game sites need this live connection, long polling connection between the players and the server. And this connection is being established on the server side, and the server runs a number of connections, and the server also allocates some resources for maintaining a pool of connections with all the players in the current game session, in all game sessions. And this connection is being used extensively, even if I don't send anything special to the server, even if I don't press any button, still there are some messages like ping that are being sent, probably in both directions, from the client to the server and vice versa. So I can go on with the current application design. implementing a board game like this. My quiz exercise was unique in this sense because all the players should go and post their answers and should learn the result of their action in certain periods of time. Each question would follow one another, and each question has a limited but also determined time for answering. So the client shouldn't wait until all the other players answered the questions. They wouldn't know if other players are doing well or not doing well, if some of the players have not provided their answers yet. That doesn't matter. I'm the player, I just see the questions, I select the option or more options, and I press answer button. And if some of the clients did the same, I shouldn't necessarily be notified. I don't have to be notified if some of the players, let's say, make his or her turn. And this notification initiated by the server is hard to achieve with the current application design. I need a WebSocket like I have here on this website. But for a WebSocket, I also need a server that will be processing the request and also maintaining a pool with of connections with clients. Of course, this serverful design does not contradict this serverless design. I can combine both, and I can still make some savings on applying AWS calculation on the server side and allocating less resources for the server that's constantly being used for maintaining simple connections with client and not performing hard calculation or I don't know other requests, other processing that requires much memory and CPU units. So this design can still be utilized, and there are plenty of applications that I could implement in this serverless manner. But the only thing I want to get rid of for the next exercise, if there is a next exercise, will be this elastic cache resource because it's expensive. I'm not using it heavily. It's not persistent. And if I replace Elastic Cache with, say, DynamoDB, most probably I would save some money. And this amount, regarding my spendings on this report page, this amount I would save in relative numbers would be substantial. Actually, there are options in case I want to use the AWS Lambda for communicating with the clients through WebSocket connections. Of course, I need a server for maintaining the connection pool, but this server could again be AWS API gateway, like I did for HTTP endpoints. But this is probably for the next exercise, and the current one has officially come to its end.